All right, welcome to this session about Azure Automation, where we are going to look at how to leverage that service to automate both hybrid and cloud environments. In this session, you're going to learn how to use Azure Automation to manage both on-premise and cloud services, being it Azure, AVS, or Hyper-V or VMware, it doesn't matter. And we are also going to try to look into how Azure Automation differs from other automation capabilities in Azure, such as Azure Functions, Event Grid, and so on. So we're going to start with a brief overview over the automation capabilities in Azure from a high-level perspective, and then we're going to dive into the automation service and the capabilities there. After the brief introduction, we are going to look into demos and a few demos more. So if you start by the capabilities in Azure, we have a lot of different services available for us to use. For example, for deploying things, we have Resource Manager, Deployment Manager. We have Azure Automation, which we're going to talk about today. To respond to events, we have Event Grid, which can be configured to respond to, for example, a VM creation event and then trigger some automation. Event Grid can trigger a massive amount of things, an Azure function or a logic app or an automation runbook. Then we have functions, which probably many of you have been to sessions about previously in this conference. And we have logic apps, which is kind of a more graphical workflow designer, very similar to Orchestrator, which had a graphical drag and drop environment for defining the logic. So if you need that kind of functionality, you might want to use Logic App for the workflow and automation or functions to put things together. So there are a lot of opportunities here. Then we have Azure Automation, which we're going to talk more specifically about today. It has three main sub-services, which we're going to look into. We are going to focus mostly on the process automation, which is basically PowerShell runbooks or PowerShell scripts in practice. But we're also going to have a brief look at the update management, which is a service for patching both Windows and Linux servers. Then we also have configuration management, which makes it possible to track installed software services that are stopping and starting and so on. And last but not least, we have process automation, which makes it possible to run PowerShell both against Azure, but also on-premise or a different cloud if you want that. So then I think we're ready to look into Azure Automation. There will be only demos from this point on. So if we start by creating an automation account, that is the first thing you would need before you get started. So I would recommend looking into the documentation. It's very good and have very good quick starts and step-by-step tutorials for things like creating an automation account on a runbook, which is a common scenario, but also many other things, managing updates and so on. So the documentation is really a good starting point if you want to look into the service. When you are going to start with this, you first need to create one or more automation account. How many you need depends on your needs. I would recommend at least one for testing and one for production. But you can also separate based on which environments you're trying to automate and so on. But for this demo, we're just creating a single automation account and having everything in the same one. Of course, you can do it from the portal. If you go into the portal, create a resource and you search for Azure Automation, you can create the automation account from here. But of course, we want to use PowerShell in this demo. So then you can use the PowerShell AZ module. Here I've already connected to the account, so I don't need to do that again. But first we need a resource group to put the automation account in. So there, that is created. Next we create the automation account, and you only have to give it a few properties. You have to give it a name, specify which resource group and what location in Azure is it going to be located in. I'm also going to import our runbook very quickly, just to show you that you also can do that from PowerShell. So it's a separate import AC automation runbook command, where you just specify the path and give it a name. But you're also going to do that from the portal afterwards. For those of you using the declarative deployments, you can also use, for example, an ARM template. Go into the portal, find the automation account, and hit the export template option here. So you get an ARM template for deploying this and having it in source control. But there are also other possibilities, for example, to leverage Terraform. For those of you who have used that, I think it was Ben who created the Terraform provider for the automation for creating automation accounts. So if the console seems to hang here, but if you just restart it. So here is a Terraform template which specifies where we want to store the state, because everything in Terraform needs to be stored in a state file, either locally or remote. Then we say that we want to use the Azure RM provider to provision resources, and then we have the Azure Automation account resource, which makes it possible to do exactly what we did, except here we have an example of using variables instead of hard coding it. So it's perfectly, if your organization are using Terraform, it's perfectly fine to deploy both runbooks and automation accounts and all of the resources you need inside of Terraform. Let me just redefine this function. And let's have a look into the capabilities that we have. So we're going to have a quick look at the basics of an automation account before we dive into the details. So if we find the automation account that we just created, this was not the one that we created. Let's find the correct one. So we created a new resource group, PSConf EU 2019, and there we have an automation account. Here we have an overview or sections based on the sub-services. So we have configuration management, update management, and process automation. So let's just have a quick look at the configuration or update management and the configuration management before we dive into the process automation ones. To have some content to show, I'm just going to jump over to a different automation account so that we have some data to look at. So if we start with configuration management, here we have basically, in order for servers to show up here, you need to deploy the Log Analytics or the Microsoft Monitoring Agent to the servers and hook them up to a Log Analytics workspace, which is connected to this automation account. So there is a link between an automation account and a Log Analytics workspace in order for these features to work. But that is also very easy to set up and good documentation for it. So here we have some computers in our demo environment where we can see where the VMs are running. So for those that are not native Azure VMs, you can see that the platform is non-Azure. So you can manage servers on any platform basically, because it's just an agent that needs to talk to the Azure service, outbound, port 443. Then you can have a central overview of which software is installed on all of the servers, including patch levels. You can choose to track files. So you have to specify which files do you want to track. Here I'm tracking a file on Windows, but you can also, of course, track configuration files on Linux. For example, for Windows, it's easy to set up tracking of the hosts file or any configuration file you want. Same goes for Windows on the registry. If there are any central application keys that you want to audit changes on, which affects production. Services that are starting and stopping, and the same for Linux. And all of the things that we see here now is available in Log Analytics, so it's possible to programmatically query this data. So in Log Analytics, we have this configuration data source, which will give us all of the information from what we just saw in the portal. So then you can configure alerts, for example, if a service is stopped, or many things that you can do based on the data that we just saw. Second, we have change tracking. This makes it possible to see over time what kind of changes there are in our environment. For example, imagine we had an outage, for example. Central application went down, and we can have an overview here over all of the things that happened in the environment. Was there any software that was updated? Were there any patches that was deployed? So we get a central overview over relevant events, basically. So for example, if we dive into the files, if I go into and change the contents of the demo, cdemo.txt file that I just created, it would show up here in a few minutes. Then we have a state configuration. That is basically a PowerShell desired state configuration pull server. So you can upload your configuration here, compile it. As you know, with desired state, you have to first create a configuration in PowerShell, then you have to compile it, and the compiled configuration is available for nodes to be assigned. So if you know desired state, it's pretty easy to get up to speed with this part. Then we have update management, which is the patching service. So here is the same concept. You deploy the same agent, the Microsoft monitoring agent. When you have onboarded that to the service, you can configure schedules for deploying new updates. So for example, here we'll have a brief overview over whether the servers are compliant with the latest patches or not. And you can configure deployment schedules. So let's go ahead and see. Here you can, of course, choose Windows or Linux. You can choose which update classifications you want. You can group your computers by some logic that you defined. You can include and exclude updates. So if there are any issues with an update, you can go ahead and exclude it, or you can just say that you want to schedule the deployment of a specific update. If there are, for example, a 0-day patch that you want to deploy as soon as possible, you can just run an update run for that specific package. Scheduling is the same for Azure Automation. You can choose to deploy it every 4th Thursday or whatever you want to do. So it can be recurring, or you can do it just as a one-time thing. You can specify how long time you want to allow the update run to be, for example, a maximum of 2 hours. And then we have this pre-scripts and post-scripts. That's pretty useful. It was added, I think it was last year. Imagine, for example, if you're using, it basically allows you to select an Azure Automation Runbook to run once before and once after the patching and rebooting has happened. So basically, one example is if you're using Hyper-V Replica and you're having 2 physical Hyper-V servers and you're replicating virtual machines between them. Before you patch one of the hosts, you want to ensure that there are no running VMs. You maybe want to fail them over, or if you have an active passive scenario, you want to suspend replication before you reboot the server or unpatch it, and you want to resume it afterwards. If not, you will get the error messages and you have to fix them manually afterwards. So that's just one scenario, but if there are updating of, for example, an application where you have dependencies, you maybe want to take a server out of the load balancer and things like that, you can do that via runbooks with the pre-scripts and post-scripts. This also works with WSS, so if the computer is configured against a local WSS server, it will get the updates from there. If not, it will get it from Microsoft Template. So this is also pretty straightforward and easy service to use. If you use Config Manager, you can also set up this to be co-managed with Config Manager, so you can continue to use Config Manager for your on-premise servers if you want, or you can choose to use this only for Linux or only for servers running inside of a cloud service. It's kind of up to you to how you want to leverage it. You don't have to use it for everything. Then we have the thing we maybe are most interested in today, which is process automation. So here we have basically runbooks, which is where you can upload the PowerShell content. So let's go back to the account that we created earlier on. Here we should have only the one that we imported. You remember after we created the automation account, we run a command to import a runbook. And here we can see that Runbook is available. If you want to create a new Runbook from the portal, you can go ahead and do that here as well. We have several types of Runbooks. PowerShell, which is regular PowerShell script. So if you have an existing script, you can basically just upload it as is, but I would recommend doing some tuning, which I'll get back to. Python scripts, Python 2, which was supported, I think it was a couple of years ago. Graphical runbooks, this is something that they created to be kind of a transition mechanism for those coming from System Center Orchestrator, which was used to having a graphical designer. So I haven't used that much myself because I'm mostly into doing things in PowerShell, but for those coming from Orchestrator, that might be a good transition option. And also previously, if you remember, after Orchestrator, Microsoft released something called Service Management Automation, which was also a part of System Center. That didn't support regular PowerShell. It supported PowerShell workflows, which was introduced in PowerShell version 3. And if you worked with workflows, you know that there are some quirks there. It isn't regular PowerShell. You have to, it's a special syntax and based on a different technology. So I prefer to use regular PowerShell, which was introduced, I think it was 3-4 years maybe in Azure Automation, that you can just use regular PowerShell runbooks. So that's what I use mostly for myself, but you have the options. For example, if you're doing things against Linux environments, the Python runbooks might be a good option. Let's just go ahead and create a demo runbook here. When you created the runbook, you will be taken to the runbook designer where you can paste the code or write the code that you want. So here you can see I can write my command. Save it, then it will be saved in kind of a draft mode, and then when I hit publish, this is the version that will be run when we actually run the runbook. So now I'm inside of the runbook. If I go back, you can see that it's available in the list. When you hit it, you can you get all of the options that you see here. So you can see the history of the recent jobs, the recent times it ran. You can schedule the runbook to run on a schedule. So for example, if you have a lot of scheduled tasks on your servers, you can consider moving them here to get them in one central place. So you get it in version control, which we'll talk about afterwards, and you don't have to manage the local task scheduler on every computer. You also have the option to configure webhooks. So basically you will get a HTTP post URL when you create a webhook. It will automatically generate one. So this can be used to trigger the runbook from some other kind of automation. Anything that can post to a URL can pass parameters and start the runbook. So we're going to have a quick demo on that afterwards against Microsoft Teams. When you start a runbook, we can also have a quick look at those options. Just hit the start button, and if you have a hybrid worker in your environment, you will get asked whether you want to run it in Azure or on the hybrid worker. You can do that in the other automation account, so you actually get the question. So here you can see, we'll talk more about hybrid worker afterwards, but basically that is also the Microsoft monitoring agent that you install on a server on-premise that you want to dedicate for running runbooks. Then it will, you can run a PowerShell command to hook it up against your automation account, and then it will show up when you start a runbook. So when you choose to run the runbook on this hybrid worker group, the runbook will pick it up within a few seconds, run it locally, and send the results back to Azure. Because then the advantage is that the runbook has access to your local environment. While if you run it in Azure, it's kind of running in a sandbox environment, which only have access to the internet, basically. It doesn't have access to the on-prem environment. That might be fine if you just want to manage things in Azure, for example, starting and stopping VMs and things like that. But if you want to do things against local Active Directory or SQL Server or what have you, you should consider using a hybrid worker. So to configure a hybrid worker, you go into the hybrid worker groups, you hit configure, then you have a link to the documentation, which is pretty good, which explains how this thing works. You can also configure a Linux hybrid worker, so you install the monitoring agent and run a PowerShell command, which is further down here, to onboard it to the automation account. So here you can see that we have examples on how you do this on Windows and how you do it on Linux, on which URLs you need to open outbound and so on. So this is something I've been using for several years at my customers, configuring an automation account with a hybrid worker group so that they can automate the on-prem environment as well, because many, when they hear the word Azure Automation, they think, oh, we can automate things in Azure, but you can basically automate things no matter where they are running, as long as a hybrid worker can be configured. Then we also have some shared resources here, for example, schedules that you saw, so you can set up schedules that can be reused across runbooks. Then we have modules, which is integrated with the PowerShell gallery. So this is modules imported into your automation account. So this will be automatically available on the sandbox worker in Azure, but they are not automatically available on the hybrid worker themselves. So you need to make sure that the modules that are available here is also available on the hybrid worker. We're getting back to an example of that a little bit later on. Same goes for Python packages if you need that. Credentials, that's another thing. You don't want to hard code credentials inside of your runbooks. So for example, if I have a look at this runbook, if I had to authenticate, if I want to use invoke command against another machine, for example, I don't want to hard code my password share. So by using Azure Automation Assets, we have the option to use a command called get automation PS credential, where I can retrieve a PowerShell credential object, for example, for Active Directory, and just use that for remote commands. So this will retrieve a credential object, and you can just use it like you do for remoting credential, and then use it like this. The same goes with the variables. There is a command called get automation variable. So instead of hard coding things like, for example, SMTP server or DNS servers or whatever information that you need in your runbook, try to not hard code it and rather reference the variables. Then you can retrieve them dynamically. If we go back to the automation account, we can have a look here that we can define them centrally. So if I have a quick look at credentials, for example, add credential, give it a name, AD, for example, admin, and the password. So this password will be stored encrypted. I think Azure Automation is actually using a key vault under the hood that is automatically managed as part of the service, so it's stored encrypted. Same goes with the variables. You can create central variables, just give it a name, for example, SMTP server, and multi-line value if you need that. And you can also choose to encrypt the variable if it contains a connection string or something that you don't want to be available in clear text. Then you also have the notion of connections, which basically makes it possible to create connection objects. If you have, for example, you need to connect to, for example, a System Center Operations Manager, then you have the server name of the management server, username and password. So you have 3 properties. This is kind of the connection objects that you can create using this feature. Certificates, pretty self-explaining. You can upload those to authenticate to services. And the keys here is the keys that you need to authenticate or onboard nodes to Azure Automation in the automation account. So that was kind of the basics of shared features, update management, change tracking, but now we're going to focus mostly on what we can do with process automation and runbooks. So one thing that is a common ask, at least among my customers, is that they want to delegate tasks to kind of power users or end users that should be able to trigger an automation job. There are no native capability to go into our runbook and say that you want to delegate access only to a single user in the GUI here. But I think it was last year, last summer, they created this feature called, or the capability to add role-based access control for Runbook. So I have an article on PowerShell magazine which explains this in detail if you're going to look into it afterwards, but I just thought I'm going to show it to you very quickly. So I have a quick demo here. So you notice that we uploaded a runbook called Invoke Robocopy Backup. So we're basically going to delegate access to that Robocopy runbook to a demo user. So here I just hard-coded the ID, so I don't have to authenticate and retrieve it here in this case, but you could, so you have to specify the user ID in Azure Active Directory, so you can retrieve it dynamically, but here I just cheated to make it easy. I have to authenticate because I restarted the shell, so I'm just quickly going to do that. Then we are using the device login. So we first need to, and we also need to set the correct context. Set AC context. Interesting. I think this might be a little VS Code bug, maybe. Let's see, we have that. Subscription ID, sorry for this. There we go. Now we are in the correct context, which is the subscription that I have the demo environment in. Then we can go back to the runbook, define the variables for the automation account and the runbook and the ID of the user we want to delegate access to. Then we need to get the resources from Azure, because when we are specifying the role assignments, we need to specify the resource ID. So here we are basically just using get AC resource to get the automation account with this name. Then I don't think I updated with the correct name here. Let's have a quick look. I think it's called this. So there we have the automation account, and here we have the runbook that we want to delegate access to. Then we run new AZ role assignment to dedicate the automation job operator and the runbook operator roles to that user, so it can basically get access to that runbook and start it and view their job history. Let's see. What was the error message? Oh, I'm using an account that isn't authorized, but you get the idea. So when I'm looking, if I'm logging into this automation account with the demo user, you can see that now I don't see any resources. But after that command has been run successfully, only the single runbook would show up. He will not get access to the whole automation account, but he will only see that single runbook and be able to start it, pass it parameters, see the job history, and so on. So for power users, it might be an applicable option to just give them access to the Azure portal directly, and so they see only that single runbook. The alternative would be to create some kind of front end which it triggers the job. Previously I created, for example, Power Apps, which is triggered via Logic App, which then triggers an automation account, but there's many steps involved. So if you want just an easy way to delegate end users access to perform things in Azure Automation, this is kind of an easy way to do it. You have to, of course, do it via PowerShell, as we saw here, but that's okay for, at least for the people in this room, I hope. Next demo, let's have a quick look. It's about Microsoft Teams. Who of you attended the bot session with Steve Lee previously? Or then you got an idea with how bots work and what you can do with them. There are many options here for creating interaction between, for example, an automation process and, for example, Microsoft Teams or Slack or whatever service you want. But in this example, we are using Microsoft Teams. So in order to trigger an automation runbook from Teams, we need to create what is called a webhook. So I showed you earlier on when we went into our runbook and we went into webhooks, we could get this URI. And that is basically the URI that is authorized to start a runbook. And you can also pass it parameters. So let's go ahead and create, import and create a runbook. If you have the demo runbook called Test Microsoft Teams, let's go ahead and import that into the automation account. And we're going to create a webhook for it. I already have this set up in a different automation account, so I suggest that we just go to that one to save some time. So if you go into another one, we should find the test Teams runbook here. And we can see in the webhook section that there is already configured a webhook against a Teams channel. So here we have the URI that we need to call it. That's something that I've already said. So when you create a webhook, it's automatically creating a parameter called webhook data. So that is a parameter you can specify parameters in. So if you need to pass in any kind of parameters, you can do it inside of the webhook data in JSON format. And you can also choose where to run it. So every time that the webhook is triggered, this is what specifies where it's going to be run. So now we have an opportunity to, from Teams, call a runbook. But how do we trigger it from Teams? That's the next topic. So here you can see at the top we have the webhook data. That is the parameter that we need to set up to parse the input. So that will contain a property called the request body, which is in JSON format. So here we're just transforming it into a regular PowerShell object. And here we need to extract the properties that we need to, for example, the requester, it's inside of this property because this is specific for Microsoft Teams. But if you're using different means for calling it, you need to check out what the properties are called. So when I start with a new scenario, I usually just save this to a CLI XML file that I can inspect manually just to explore the properties and have a look at it. So in this scenario, this runbook is going to reboot Azure VM. Then I have to parse what is the VM name. I'm kind of cheated. Suppose a regular expression would be more appropriate. I think Steve showed an example of that. But this does the work just for this demo. And then when you have performed the action, you can of course here type restart VM and go ahead and find the VM that the requester wanted, and then go ahead and post something back to Teams to let the user know that the request is accepted and is going to be run. So for that, I'm using this module called PS Teams, which is available on the gallery. Here you can specify a URI that you have to configure in Teams. I'm going to show you that in a minute. And then you can just go ahead and create Teams artifacts to post things back to Teams. So this demo doesn't actually restart the DM, it's just a proof of concept for restarting it. So now let's go ahead and look, how did I create this URI to post back to Teams? So if we go back into a Teams tenant here, we go back to Manage Team, and we go to Apps. At the bottom right here, we have this option called Create an Outgoing Webhook. So here you can give it a name. Here is where you create the callback URI, where you are going to specify the webhook URL for the Azure Automation runbook, and you can let's have a look at the one I created here. I just uploaded a custom image, and here you can see the URL to the Runbook. The next thing, in order to make it possible to send things back into Teams, is to create an incoming webhook. So when you create an incoming webhook, you can you get a URI for posting back to it. So if I look in this channel and the incoming webhook, when you do this, you will get an URI that you specify in the Runbook in order to post back. So let's have a quick look at how this works. If I'm going to trigger it, in order to call it, we have start Azure VM, which was the name of the outgoing webhook. So just add and name of it, and then you can pass it values. So for example, VM123. We are going to get an error message here now, because as Steve told us earlier on, the Microsoft Teams service is expecting a reply within a few seconds, and from Azure Automation we have no option to respond to that request. We can only retrieve it. So in order to do that properly, I didn't have time to it for this demo since it's just a proof of concept. What would have worked is to make a Azure function proxy for this. So the Azure function is being called. It can respond with an OK back to Teams, so we don't get the error message, and the function can then trigger the Azure Automation Runbook. That would that way we can acknowledge that we received the request, and we won't get this error message. So here you can see that we already got the response, and we got the link, so the user can just hit the View Azure Automation job and get a link directly to that Runbook. So if you go into the history of that Runbook now, we should see that it ran just a few seconds ago. So here you can see 1 minute ago it was running when I called it from Teams. Here you can see the JSON that was passed by Microsoft Teams. So this is containing all of the information about the channel ID and things like that. So here is where I parsed the name of the VM that I want to restart. So if you look at the output, you can see that I'm just outputting that I got a request from the name of the user and which VM to reboot. So this is kind of a proof of concept to show what the possibilities you have here. If you want to look into bots, I would also recommend looking into Poorspot, which is kind of a pretty awesome framework created by Brandon Olin, which supports both Slack and Teams. Setting this up requires kind of more resources than I had the time to look into, but here you basically see how it works. It's using Azure functions, dropping into service bus, and so on. But this makes it even more flexible, so you can create commands that the Poorspot can receive, and those commands can run not only against Azure Automation, but it can basically run any PowerShell command from the server you set it up on. So if you're interested in a pretty flexible way for automating things from a bot in Teams or Slack, I would recommend looking into the Poorspot. It's pretty awesome. Post pre-actions I mentioned earlier on that you can trigger when using update management. Last demo I think we have time for is showing how you can trigger an alert to in Azure Monitor to trigger an automation runbook. So Azure Monitor, it's a service that you can use to monitor, for example, performance data, event logs, and so on from your servers. So it uses the same agent I mentioned earlier, the Microsoft Monitoring Agent, which is being attached to our Log Analytics workspace. Then you can act upon alerts from that. So if you go into an example here, if you find a Log Analytics workspace, and we can query for disk space. If you go into the log section, here we can type the query we want. Here we have a query called perf that will basically search for the percent of free space available on the C drive, and if the amount is under 10%, it will trigger a result. So here you can see that it triggered a result when doing some testing earlier on, but now I'm going to simulate disk being filled. So if I go into a server which is hooked up to that monitoring system, Here you can see that the size remaining is 111 gigabytes. Inside of this temp folder, I'm just going to create a dummy file. So let's go ahead and create, just using fsutil, I'm creating a 100 gigabyte file just to fill the drive to simulate a failure. So now it's under 10%. So let's have a look at how the monitoring works, what will trigger this. So when you have the query set up here and you can see that it's working, you can hit the new alert rule in Log Analytics. You can say what condition do you want it to fire upon. So here you have the query that you typed, filled out. And if the number of results is greater than 0, then I have at least one computer with a full disk. During the last 5 minutes, for example, then I want it to fire. And for the actions, here you can, for example, configure action groups that sends emails and notifications to teams and all that. But in this example, we are using invoke disk cleanup, which is an Azure Automation runbook that is being kicked off to remediate the problem. So let's have a quick look at how that runbook looks like. I think I have it here. Invoke disk cleanup. Also, this is just a proof of concept, so it's not something that is production ready, but it kind of shows the possibilities that you have. So here we have the credentials that will be used for connecting to the target computer. Here I'm sending an email notification via Office 365 after the remediation has taken place. And the recipients of the notification is being retrieved from an automation variable, so I don't hard code that in here. And here is also a technique I mentioned when troubleshooting or setting this up. Just export CLI XML to a XML file so you can import it and play with it interactively just to figure out what the properties are and how you should parse it. So in order to parse the required properties for this one, I used the
Oh, you can hear me anyway. Anyone interested in WPF or XAML editors, just stay in
where is the sound coming from?
Stay here for a while, and I'll try to set this up in 3-4 minutes.
Yeah, we are here. I'm parsing, so all of the parsing, the credit is to Cameron Fuller, which is a guy working a lot with Azure Monitor, which parses the results, because we have a table here with rows and columns, which represents the search results from the Log Analytics query. So here is basically parsing out. Then, when we have retrieved that, we have the name of the computer or the computers with low disk space inside of $computers, and then we just do a for each against it, use regular PowerShell remoting, and here I'm reading when the last disk cleanup was run, just so I don't do it again and again within a short amount of time. Then I am just using the dism commands to clean up the Windows Update component store in this case, and I'm also just deleting things from the temp folder where I created that dummy file. But here you could, of course, do many more things if you want to. If you already have logic to clean up things on your servers, you can go ahead and put it inside of our runbook like this and have it automatically remediate. So if you go back into the automation account just quickly before we round things off here, we should see that runbook has been triggered automatically. So if we find a runbook called invoke disk cleanup, it might take a few minutes because I think I set it to check for every 5 minutes. I know it haven't been 5 minutes, so just have a look at the previous one, the output from that. So here you can see that this is the output from analyzing the component store, and after that has completed, it will send an email to an operator that how much space was available before and how much was available after. And yeah, that's basically it. I think we have to go back to the slides and round things off here. So in this session we had a look at the automation capabilities in Azure Automation. We had a quick look at update management for patching Linux and Windows, configuration management, which is basically the PowerShell DSC pull server. We also had a brief look at the possibilities we have in process automation. Specifically, we looked at the PowerShell runbooks, which could be triggered by schedules. We could trigger them via webhooks from Microsoft Teams or Slack. And the official guidance or at least when I talked to Eamon O'Reilly, which is or an email conversation where he stated some things about which service should you use for what scenario. Is Azure Automation dead? Should we use Azure Functions for everything now? So the guidance from his is to use the new services such as Azure Functions, Event Grid and so on for their specific scenarios. For example, reacting to events in Azure. Then it makes more sense to use Event Grid and have that trigger the automation instead of trying to do clever things from a Runbook, for example. But my opinion, at least, is that Azure Automation, it won't go away anytime soon, even though it doesn't seem to be developed as much as it was before. It's still very applicable for on-premise automation. So if you're doing things against local resources, using a hybrid worker is the perfect solution in my opinion, because then you don't need any VPN in order to connect back to on-premise. For example, if you want to connect to on-premise from an Azure function, you can integrate it into a virtual network which has a VPN connection down to on-premise, but the bar for doing that is kind of higher. So I think for on-prem automation, Azure Automation gives us more flexibility. But over time, we will of course see that the functionality and the investments Microsoft is doing is kind of going to other services. But Azure Automation is still very, very much alive. Because of the technical issues in the beginning, I don't think we have time for any questions now, but feel free to hook me up afterwards. The slides will be available. If you find me on Twitter, I'll post the links to the demos and slides a few minutes ago. Key takeaways, take the time to automate. Throw it in tough time. Hit me up afterwards, and thank you very much for attending.